Determine whether the following series is convergent or divergent. If it is convergent, find its sum. In part A, we got 7 over pi raised to n. Pi is an irrational number whose value is about 3.1419. So what we can do here is, this 7 has nothing to do with sum, because sum is for n from 1 through infinity. We can pull 7 outside, or we can keep inside, doesn't matter. Let's keep inside. Then this is, we can write in this way, 7 now 1 over pi raised to n from 1 through infinity. So this has the form of a r n, or just a can be pulled outside, r raised to n, and that r raised to n means geometric series. Okay, this is a geometric series, and we know that if absolute value of r, if r is less than 1, this series converges, and we can find the sum. That is first term over 1 minus r. Okay, it's the first term over 1 minus r, and 1 over pi being about 3.14, 1 over pi is less than 1. That means this series converges. So let me write that. So this is a geometric series with common ratio 1 over pi, which is less than 1, so converges. So converges being a geometric series with absolute value of r is 1 over pi, is just the positive number, so just 1 over pi, which is less than 1. So this converges. Now we can find the sum. For we need to find first term. First term A is, look at here, this starts from n equals 1. Plug in n equals 1 here, then we get the first term. So this is 7 times 1 over pi raised to 1. So 7 times 1 over pi, which is 7 over pi, first term, and common ratio is 1 over pi. So the sum is first term over 1 minus r. That is 7 times 1 over pi, that's on the top, first term, or 7 over pi. This is same as 7 over pi, all over 1 minus r. R is 1 over pi. We need to subtract, do not cancel anything yet. 7 over pi over 1 minus 1 over pi, we need to make common denominator. 1 is pi over pi, so we have common denominator of pi, then pi minus 1. Okay, I just combine these two fractions, and that's what I get. Next, 7 over pi divided by pi minus 1 over pi. Change this division into multiplication. This pi and pi cancels. Okay, after they cancel, the final answer is 7 over pi minus 1. So if we sum all the infinitely many terms, the sum will be 7 over pi minus 1. So here is another series. Let me simplify this. N from 1 through infinity. 8 raised to n plus 1 means 8 raised to n times 8 raised to 1, or just 8, times 9 raised to negative n. Okay, n from 1 through infinity. 8 raised to 1 is just 8. I'm writing number first. 8 raised to n, 9 raised to negative n. If we put this on bottom, then 8 over 9 raised to n. 8n, that's on the top. 9 raised to negative n, that goes on the bottom. Again, this is ARN, a geometric series, and r is 8 over 9, which is less than 1. Absolute value of this is less than 1, so it converges. So converges being a geometric series with absolute value of r, common ratio, absolute value of common ratio is 8 over 9, is positive, so we don't have to even worry. That is less than 1. Okay, if this common ratio absolute value of common ratio is 1 or bigger than 1, then the series diverges. Now it converges means we can find the sum. To find the sum is a first term over 1 minus r. So we need to find first term. First term is, okay, just don't say 8 is first term. No, we need to plug in n equals 1 here. Okay, the same thing like previous question. Plug in n equals 1. So 8 times 8 over 9 raised to 1. 8 over 9. So 8 times 8 over 9 means 8 times 8, 64 over 9. That is first term. Then now we can find the sum. Sum is first term over 1 minus r. Our first term is 64 over 9 divided by 1 minus r. R is, the common ratio is 8 over 9. Okay, it can be positive or negative. 8 over 9. Now we can combine this. So 64 over 9 divided by 1 is 9 over 9. 9 over 9 minus 8 over 9. So 1 over 9. 9 cancel on the bottom. So 64 over 1. Just 64. Okay. Here same thing. Let's simplify. N from 1 through infinity. Negative 3 raised to n minus 1. Let's do this. Negative 3 raised to n times negative 3 raised to negative 1. N minus 1 means negative 3 raised to n and negative 3 raised to minus 1. Because I saw 5 raised to n, so I want to make something raised to n on the top as well. All over 5 raised to n. Okay. Next, let's simplify further. This negative 3 raised to negative 1. So it's 1 over. If we put 1 over, this negative will be positive. So 1 over negative 3 raised to positive 1 is in fact negative 1/3. So this term, this factor is this. Now we can combine these two because power n. So negative 3 over 5 quantity raised to n. Negative 3n on the top, 5n on the bottom. So again, this is like something a r n. Okay, the geometric series with common ratio negative 3 over 5. So what is the absolute value of negative 3 over 5? 3 over 5, which is less than 1. So this series also converges. So we can say converges being a geometric series with absolute value of r. When we find absolute value of r, that's 3 over 5 less than 1. Okay, now we can find the sum. We need first term. First term, a means plug in n equals 1 here. So negative, this is 1 over negative 3 means negative 1/3 times negative 3 over 5 raised to 1 means just negative 3 over 5. 3 cancel, and negative times negative positive, so 1 over 5. So this is just 1 over 5. So we have the first term. Now sum of the series is first term all over 1 minus common ratio. Common ratio is negative 3 over 5. Okay, this is negative 3 over 5. So 1 over 5 on the top. 1 minus negative means plus 3 over 5. 1 over 5. We add these two fractions. 1 is 5 over 5 plus 3 over 5. So 8 over 5. 5 cancel. After we flip this fraction, then it is just 1 over 8. Okay, so if we add all the infinity many terms, this comes out to be a final number 1 over 8. Okay, final